All right, this is going to be our walkthrough for the assignment titled Mean Value Theorem for Derivatives. So all we're going to be doing here is verify the hypotheses of the mean value theorem. And then if those criteria are both met, then we just need to go through and find all of the values that satisfy the conclusion of the theorem. So the two things we have to check for all of them is f continuous on the closed interval that is given to us? And this one clearly is. That function's a polynomial, so we're going to say f is continuous on 0 to 6 because it's a polynomial, and that's a sufficient reason always to determine that a function is continuous as long as it's actually is a polynomial. Same with being differentiable. We're going to say that f is differentiable on the open interval from 0 to 6, also because it's a polynomial, right? All polynomials are continuous and differentiable for all real numbers, and that is clearly a polynomial, so it must be. So that tells us that there is guaranteed to be, so we'll say that the MVT applies, and the idea is that there must be a place where f prime of c is equal to f of 6 minus f of 0 over 6 minus 0 on the interval from 0 to 6, right? For some c on the interval 0 to 6. And so all we need to do is figure out what that is. So we do need to find f of 6 and f of 0. Right? So f of 0 is easy. F of 0 is just 4. F of 6 isn't so bad either, really. It's 6 squared, which is 36, minus 5 times 6, which is 30, and then plus 4, so that just comes out to be 10. Okay. So we know that f prime of c, well, what's f prime of x? F prime of x is 2x minus 5. So f prime of c would be 2c minus 5. We want that to be equal to f of 6 minus f of 0 over 6 minus 0. Well, that just comes out to be 1. So we have 2c minus 5 is equal to 1, or c is equal to 3. Okay? And we can see that 3 is clearly on the interval from 0 to 6. That's all there is to it. So for this next one, we should be able to immediately state that f is continuous on the closed interval from 1 to 2 and differentiable on the open interval from 1 to 2 because it is a polynomial, right? X cubed minus 4 is still a polynomial, so that reasoning should still apply. We do need to figure out then what f of 2 is and what f of 1 is, and also what f prime of x is. So f of 2 is 2 cubed, which is 8, minus 4, so that'll be 4. F of 1 is 1 cubed, which is 1, minus 4. 1 minus 4 is negative 3. And f prime of x, we just use the power rule on it to get 3x squared. So this tells me that, according to the mean value theorem, since the conditions have been met, it's continuous and differentiable on that interval, that f prime of c, or 3c squared, should be equal to f of 2 minus f of 1 over 2 minus 1, or that 3c squared is equal to 7 here. Right? And c squared is then 7/3, which tells us that c is equal to plus or minus root 7/3. Now, you don't want to give me that answer because we are only interested in the values that satisfy it on this interval. Negative root 7/3 is not on the interval from 1 to 2. So we will say, so only root 7/3 as our answer, because c must be on the open interval from 1 to 2. So sometimes you may get more than one solution. You only want to pick the solutions that are on the given interval. All right, for our next one here, we've got x to the 1/3. Right? It's a cube root function. You can cube root any number. Cube root functions are continuous for all real numbers. So we're going to say that f is continuous on 1 to 8 because, cube root functions are continuous. And that's just a known fact, right? Cube root functions are continuous as long as it's just the cube root of x. It's continuous for all real numbers. Now, we do have to worry about the derivative here, right? So f prime of x, so we do need to see what it is. It's 1/3 x to the negative 2/3, or 1/3x to the 2/3. Right? Well, this does not exist, and this is undefined if x is equal to 0. So this function is not differentiable for all numbers, but it is differentiable on the interval from 1 to 8 because 0 doesn't occur on the interval from 1 to 8. So we will say that f prime exists on 1 to 8, the only discontinuity of the derivative being at x equals 0. So f is differentiable on 1 to 8. No other reasoning needed other than we've shown that the derivative only is non-existent at 0. Okay? So now we need to find f of 8. F of 8 is just 8 to the 1/3, that's 2. And we need to find f of 1, which is the cube root of 1, that's 1. We don't need to find f prime of x because we just did it here because we actually had to do a little bit of work to determine the differentiability of our function. So now, because we've met the criteria of the mean value theorem, we can just go in and say that our derivative, right, which is 1/3, and we'll say at c to the negative 2/3. So I'll write this as 1/3c to the 2/3 is guaranteed to be equal to f of 8, which was 2, minus f of 1 over 8 minus 1. Right? So we've got, what we've got here then is that if we cross multiply here, we're going to have 7 is equal to 3c to the 2/3. And that'll tell us that 7/3 equals c to the 2/3. To undo a power of 2/3, we'll have to raise that to a power of 3/2. Right? So c should equal 7/3 to the power of 3/2. And I'm fine with that answer. If you want to cube it and then just write the square root of that, that's fine too. But 7/3 to the 3/2 is a perfectly fine answer. For our next one here, we've got x to the 2/3 minus 5x plus 1. So first off, we have to determine if this function is continuous, right? And it's a 2/3 power function, but really that's just like the cube root of x squared, and I can cube root any number. So this is still f is continuous on the interval from -1 to 3 because it's a cube root function. Cube root functions are always continuous. And then we need to find the derivative, so f prime of x, which is going to be 2/3 x to the -1/3, or 2/3x to the 1/3, minus 5. Right? And so I think we can see that the only thing that's going to make this undefined is if that denominator is equal to 0. So this is undefined if x is equal to 0. Right? And so then we will say, well, 0 is on this interval. So f is not differentiable on the interval from -1 to 3. The MVT does not apply. And that's it. We'll just move on to the last problem on this assignment. So anytime you come up with a place where the function is either not continuous or not differentiable on the interval given, just give a reason why and say the mean value theorem doesn't apply. for our last one here, we're just going to, again, do the same thing. Exponential functions are always continuous, and exponential functions are also, should always be differentiable. So we'll take the derivative here just to look. F prime of x, though, is going to be 2e to the 2x, right? That always exists. So we can say that f is continuous on 0 to 1 and differentiable on 0 to 1 because it's an exponential function. It's just kind of a basic exponential function, and exponential functions are always continuous and differentiable. So then we need to find f of 1 and f of 0. F of 1 is e squared minus 1, and f of 0 is e to the 0, which is 1, minus 1. So f of 0 is just going to be 0. So now, according to the mean value theorem, since the conditions have been met, f prime of c, or 2e to the 2c, should equal f of 1 minus f of 0 over 1 minus 0. In other words, 2e to the 2c ought to equal e squared minus 1. And so we'll divide by 2. So we're going to get e to the 2c is equal to e squared minus 1 over 2. In order to get that 2c out of the exponent, we'll have to take the natural log of both sides. The natural log, in fact, I'll write this, do this in a different color here just so we can see we're adding kind of into our previous equation here. We're going to take the natural log of e to the 2c and the natural log of e squared minus 1 over 2, right, which just gives us 2c on the left side is equal to the natural log of e squared minus 1 over 2. Now we'll just divide by 2. In other words, that's giving us c is equal to 1/2 the natural log of e squared minus 1 over 2. And this answer is perfectly fine. Of course, you could bring that 1/2 inside the logarithm as an exponent. So you could write the natural log of the square root of e squared minus 1 over 2. Or you could break it down using the log rule for natural log of a over b. Any sort of manipulation of this would be fine, but I would also accept this answer as a perfectly good answer. And that is the end of our walkthrough for the mean value theorem for derivatives homework assignment.